In the geometry step, we will define the domain over which we want to solve our governing equations. And if I go back to one of the pre-analysis slides, the domain is a rectangle with a width of 1 and a height of 2, and we'll work in SI units. Let's input that into ANSYS. So start ANSYS, so start all programs. I have 16.1. If you're working with this free student version, you'll be running 16.2, and Workbench 16.1 or 16.2 or whatever version you're using. I'll click OK out of there and drag steady state thermal into the project page. And you see we have a bunch of analysis systems, and really what you're changing when you change the analysis system is the mathematical model we want to solve. And steady state thermal will give us, will solve the steady version of the heat conduction equations. And we have a 2D problem. So right click on geometry and select properties. And under analysis type, select 2D. And this tells it that, oh, the temperature varies only in 2 dimensions. And in our case, by default, it varies in X and Y and not in Z. This is something you need to do right at the start. You can't go halfway through and then, do it as 3D and then come back to 2D. And I've done this, several times, and I've pulled out my hair, and you can see kind of the result of that. So that's something to keep in mind if you're doing a 2D problem. And then double click on geometry to start the geometry engine, design modeler. And we will input the geometry in 2 steps. We need to sketch it, and then we need to create an area from the sketch. And we'll create our sketch on the XY plane. So click on the XY plane and say look at plane that I'm sketching on. Go into the sketching mode and select rectangle. And before that, it's a good idea to double check that your units are right. So we're sketching in meters, which is what we want. And it's also a good idea to check on constraints. That the auto constraint option, so if I move this down here, is turned on. In version 15, it was not turned on by default, and that created problems for students. So make sure that's turned on, and we'll see the effect of that in a moment. And come back to draw, rectangle, and hover over the origin until you see the P, and that means that the cursor is now coincident with the point, and the point is the origin. And that's what the auto constraints does. And then draw a rectangle starting with the P, any dimension, and then go into the dimensions toolbar and just click on that length and put in a dimension, and click on that and put in a dimension. And I can come down here, and our width is 1 and our height is 2. And I can zoom in using the right mouse button, okay, or I can zoom in using the middle mouse wheel, and I can move the dimensions. So if let me expand this over here and say dimensions, move, and move it over here. And I like to display the values, so I'll deselect name, and so it'll give me the values. And I can say zoom to fit, or I can zoom in, and again, I can move it a little bit more and so on. I won't worry about that over here. And that gives me the sketch, and then we need to convert the sketch into an area, and that I do by concept surfaces from sketches. And I can click on anywhere on the sketch and say apply. So it's going to create that area from the sketch, and then you have to say generate. Okay, so that's created the sketch, and under this one part one body, it shows you the surface body. I can turn off the sketch here, okay, and I have the rectangle that I want to solve the governing equations over. That's, you know, I have the domain, and this is what is sent forth into the solver. And in fact, you know, now because I drag steady state thermal and set it to 2D, ANSYS knows that I want to solve the, so it knows that I want to solve k d squared t dx squared plus d squared t dy squared equal to 0 over this rectangle. And it's going to use the value of k for steel by default. And that it knows because we drag steady state thermal into the project page, and we set it to 2D. And we will next save the project and then move on to meshing.